All right, welcome 7th grade to lesson 4 in chapter 3. Today we're going to be talking about solving equations containing decimals. So this is very similar to just a few lessons or chapters ago when we were solving equations using addition, subtraction, multiplication, and division. And now we're just saying that you can do the same thing when you have decimals involved, okay? So let's take a peek at our first example. It says to solve and then justify your steps. Okay, so we're given the equation n minus 2.75 equals 8.3. Okay, what I need to do is go back to my rules for equations and ask myself that ever important question of what is being done to my variable and how do I undo that? Okay, again, some helpful hints. You can split your equation at the equal sign, so you have a left and a right. You're asking yourself, what number, when you subtract 2.75, gives you 8.7 or 8.3? And remember, we're trying to isolate our variable. All right, well, n is being subtracted by 2.75, so to undo that, I would add 2.75 to both sides of my equation. Okay, so subtracting 2.75 and adding 2.75 undo each other, and I'm just left with n equals, and then I just have to add these two together. Okay, so again, I'm going to use the addition property of equality because it was subtracting, so to undo that, I would add on both sides. Okay, so add 2.75 on both sides. And that's just the same right here. I'm just saying that I'm going to add 2.75 to both sides of my equation. Whatever I do to one side, I have to do to the other. Okay, then I can just add. So remember, when you're adding decimals, the trick is to line up your decimal and bring your decimal straight down. Okay, I have nothing here. I can add in the placeholders of 0. 0 plus 5 would give me 5. 7 plus 3 would give me 10. Carry my 1. 8 and 1 is 9, 10, 11. So I'd come up with 11.05. Okay? So really, knowing those tricks to solving equations is going to help you here. And then also, in the same breath, remembering the rules that you need to follow when adding and subtracting and multiplying and dividing decimals as well as integers. So we're kind of putting everything all together here. Okay, let's do letter B next. It says a plus 32.66 equals 42. So what number plus 32.66 is going to give you 42? All right. You can ask yourself the question, what is being done to my variable and how do I undo that? Okay, well, A is being added by 32.66. So to undo that, I would subtract 32.66 on both sides of my equation. Okay, adding that and subtracting it are opposites of each other, so they will cancel, and then we'll have our variable isolated. Okay, I'm using now the subtraction property of equality, and I'm subtracting 32.66 on both sides of my equation. Okay, kind of seems repetitive writing it that many times, but that's okay. And then we just need to subtract. So again, this time I'm going to have two placeholders of zeros. Okay, 0 minus 6 I can't do. I'll borrow. I don't have anything to borrow from, so this will become a 9, and I had to borrow one from here to get something to borrow from, and then make that a 10. So 10 minus 6 will be 4. 9 minus 6 would be 3. Bring my decimal straight down, and borrow again. 11 minus 2 would give me 9. And and 3 minus 3 is nothing. So I'd end up with 9 and 34 hundredths. Okay. When we move on to our next example now, you'll see that we're dealing with another operation. We're not adding and subtracting this time, but we're dividing. So it says x divided by 4.8 equals 5.4. Okay, we are dividing. So to undo our division, we would multiply. So x divided by 4.8 equals 5.4. Okay, to undo dividing, multiply by 4.8 on both sides. Okay, multiplying by 4.8 and dividing by 4.8 are opposites, and they will cancel each other out. And we'll be left with x equals, and we just need to take 5.4 and multiply that by 4.8. Okay, in other words, we're using the multiplication property of equality, and I'm multiplying by 4.8 on both sides of my equation. Okay, and then let's do that math. So I've got 5.4 times 4.8. Remember now, when we're multiplying, what's important is we line up our numbers. In this case, our numbers and our decimals line up. It's just a coincidence. So 4 times 8 would give us 32, carry my 3. 8 times 5 would be 40, plus 3 would be 43. Placeholder, 16, carry my 1. 20, 21. Okay, add these up, and I have 2592, and then I had one number after the decimal here and one number after the decimal here. So 1 plus 1 would give me 2 spots that I need to move my decimal in the end. So 1, 2. I'd come up with 25.92. Okay. If I were to round these two numbers, this would round to 5, and this would round to 5, and this would round to roughly, well, I could round it to 25. Is 25 divided by 5 equal to 5? Yeah, it is. So my answer is definitely reasonable there. Okay. Go ahead and flip to the back, and we'll try letter B. And you probably guessed it, but the only operation that we haven't done yet is the division property. So that's what we're going to do for letter B. I'm running down on time here, so I'll stop here and pick up in the next video. And picking up with letter B here for the second example, we've got 9 equals 3.6 times D. Okay, so what I'm going to do is I'm going to use the division property of equality here. Well, let me grab my pen up here. And to isolate my variable, I need to divide by 3.6 on both sides. So use the division property of equality. Okay, if I divide this side by 3.6, 3.6 divided by 3.6 is 1D. Perfect, I've isolated it. And then I need to divide by 3.6 on the other side. Okay, so remember now, for dividing decimals, we've got 9 divided by 3.6. And I need to move this decimal over one spot so that it's a whole number. And then I have to do the same thing in my dividend. So this becomes 90 divided by 36. Okay. Well, 36 would go into 90 only 2 times, which would be 72. And subtract, and you'd be left with 18. Okay. And since there's nothing else to bring down, I need to put a decimal and an imaginary 0 and bring that down. Okay, and then 36 goes into 180 how many times? Well, if you round this to 4 or 40, 40 times 5 would be 200, and that'd be close. Let's try it. Let's try 5. 36 times 5. 6 times 5 is 30. 5 times 3 is 15, plus 3 is 18. Perfect. Yeah, it is 180, so I'd have nothing left. So D would equal 2.5. And here, again, you could just show you're dividing if you want. But remember, think 9 divided by 3.6 is the same thing as 90 divided by 36, just what we showed over here. Okay? So that's solving equations with decimals using addition, subtraction, multiplication, and division. For our last example that we'll do together, it's a word problem, and it breaks it down into different steps for us, okay? So at first it says a board game box is 2.5 inches tall. A toy store has shelving space measuring 15 inches vertically in which to store the boxes. How many boxes can be stacked in the space? Okay, I usually like to make myself a drawing. So here's my shelf. Okay, in between these shelves, it says, so from like here to here, I'll just do this top shelf. There's 15 inches. And each board game is 2.5 inches. Okay. I know that's not to scale, but this is just my visual. Okay, how many board games could I fit in this spot? Okay, in that shelf. Right. So it says rewrite the question as a statement. In other words, find the number of boxes that can be placed on the shelf. And our important information is that each board game is 2.5 inches tall, and the store has shelving space measuring 15 inches. Okay, so if we're going to make a plan for it, the total height of the boxes is equal to the height of one box times the number of boxes. All right, since you know how tall the shelf is, you can write an equation with B being the number of boxes. We don't know how many boxes can fit on there, but we could write an equation. Well, I'm going to give you guys a little hint here, but each, a lot of times in math, means to multiply. Okay, so we want to know, well, how tall is each box? Each box is 2.5 inches tall. So if we took 2.5 inches and multiplied that by the number of boxes we have, that should give us our total amount of space. Okay. Let's flip to the next side to continue this problem. So here's our equation of 2.5b equals 15. How would we go about solving that? Well, we would divide to isolate our variable of b. So I'd divide by 2.5 on both sides because b is being multiplied by 2.5. Okay. And they actually have a misprint here. This should say 15, just like it is up here. So we divide by 2.5. Okay, so 15 divided by 2.5. Make this a whole number. Move this one spot and add in a 0. Okay, now I'm asking myself, how many times is 25 going to 150? Well, what's nice is think about 25 as a quarter and 25 cents. Okay, if I have 4 quarters, it's $1. Well, I need $1.50. So I need to add 2 more quarters. So that'd give me a total of 6. Okay, so 6 boxes can be stacked in the space. And what it wants us to do is just double check that. You can round 2.5 to 3 and estimate how many boxes will fit in one shelf. Well, 15 divided by 3 would give us 5. And so our answer of 6 boxes is reasonably close and makes sense. Okay, I'll leave you with the last 3 check it out problems. Please make sure you're pausing the video, showing your work, and going through the steps, because that's what's going to make you better at this math. Okay, do that now. All right, hopefully you've had a chance to work these out. You'd have to subtract by 27.51 on both sides. So you'd get an answer of 8.49. That's kind of looks like a crayon. Maybe I'll use a different color here. Kind of tough to see. And number 2, you'd have to divide by 2.5 on both sides. So you should come up with D equals 3.6. And lastly, you're doing something similar to what you did before. You just take your total amount of space and divide it by how tall each canned good is. So 18 divided by 4.5, and that would give you 4 cans. All right. So pretty much we're putting decimals together with equations now. And good luck with this section. If you need more help, please come see me. I will be happy to help. I will see you next time.